25, like 25, 25 into two wells, cut both wells, and then purify the air from there. Okay. Yeah. So I think should we proceed with media preparation first, or just cast the agarose gel and then dedicatedly media preparation? I'll just make the DNA gel first, and then we will start the. Okay. So we have two gel cassettes. So gel apparatus here. So this one is small. This one is big. Actually, I'll prefer this big one because I like to load them in such a way that there is a gap in between. Then it will be easier for me to cut that band of interest. Okay, so I'll use this big one. And whenever you work with DNA, this area is actually contaminated area, you can say, like, because we use lithium bromide for gel staining. So whenever you come to this area, it's better to use nitrile gloves, not gloves. Okay. I'll just change my gloves.
I think the lithium bromide is a carcinogen.
Yeah.
So just be careful.
Dangerous.
Not really.
When you work with lithium bromide, you need to be a little bit careful. The record, you are recording, so.
Okay, safety first.
Yeah. So I'll use this tray. And it's weird. One is 20, well, one is 50. This is yes, I'll use this 15 comb because we have only 4 samples plus 1 molecular weight later, that's 5. So if I like to put in between gaps around 10, 12, the best. So this 15 well comb, I think it should be enough. Okay. Yeah. So we need to make the agarose gel. For agarose gel, we can make it 0.8% to 1.2% agarose gel. Usually I like to make it 1% agarose gel. And for this large tray, we need around 120 mil of TBE. Oh, so the point is, like, we are going to use this buffer TBE, Tris 48 EDTA. TBE buffer 0.5. What do they mean by 0.5 times? Yeah, actually we have a 5 times concentrated TBE. From there we just diluted 10 times to make it 0.5 times TBE. And this is our running concentration. So I need this, to make the gel I need around 120 mil of TBE and 1% agarose. That means how much it will be? 1 point something. 1.2, is it 1? Yeah, 1.2 gram of TBE. Okay, so I will use this bottle. The one will be helpful for autoclaving. So in this bottle I have labeled like without lithium bromide. So that means first I will take around 1.2 gram of agarose in it. Then I'll pour my buffer up to around 120 mil, and then I'll just autoclave, not autoclave, just boil it, microwave it, and then pour it here, and just add lithium bromide in it. That's it. It's easy. So to get around 1.2 gram of agarose, this one agarose, right? Agarose, yes. Sean.
Yep.
I'm using yours. Is it opened or not yet?
Oh, I don't know. Should be.
Do you guys have any idea like what will happen if we use low percentage gel or high percentage gel? What will be the
You should stick what you're rubbing.
Yeah. So high percentage gel will allow you to resolve low, the small size DNA. Yeah. So high percentage gel will allow you. So actually I'm making it. I just took 1.3 gram. So high percentage gel we use usually if we have a DNA size of less than 500 base pair, then it's better to use high percentage gel. Okay. If we like to see only the vector, so in this case, what's the size of our insert? That's also important.
I think it's like maybe 400 to 700 base pairs.
Oh, so
Yeah.
then I think it's better to make a concentrated gel. Like then we'll be able to see the lower band. Otherwise we miss it. So I'll just take it. Maybe 1.5%. Even if you go up to 2%, doesn't matter. Am I clear to you guys why I just said a little bit more agarose in this case? Because our insert, if you recall, like we will have two bands from the PMK vector containing G. One will be only insert portion and the rest will be the vector backbone. So we like to cut and purify our insert portion at the bottom. Like it will be around 700 base pair, right? So that's why I like to make a little bit thick gel, or high percentage gel.
What would be the size limit for high percentage? Like, where would you say, oh, I should use low percentage instead of high?
Oh, you mean like what?
What base pair, like?
No, there is no such things. But the idea is you should use high percentage gel for lower base pair. Just and I'm not sure. There may have some great clear cut stuff like say you should use at least 1.5% to resolve 200 base pair, but I'm not so sure.
Would it just take much longer to like separate it?
Yeah. So if it is high percentage gel, it will take a little bit longer time to separate. Yeah, that's also important. So I just took my egg roll in. I'll add. Is it 1.2? Yes.
I'm not sure if we have this buffer or not. So we might have to make up the TBE point, yeah.
You should be able to make a big step.
Yeah, it's pretty simple. I think
Yeah.
3 ingredients. So.
Yeah, it's just trace and EDTA. Trace, boric acid and EDTA, that's it. Nothing else.
Yeah.
So now, yes, we just need to microwave it. Yep. Sorry, microwave. We still have our microwave machine Again, when you are going to use the microwave, make sure it's not tightened, fully tightened. Just lose it. Usually,
Oops. Oh, sorry.
I should go for around 2.5 minutes. Does it look clear? Yeah.
Looks pretty good.
It is clear, then we can use it. Yes, should be fine. It's hot, sorry, it's hot. Water here, just like to leave it for like maybe next couple of minutes. Then it will be cooled down easily. You know what I mean?
Sorry.
Yeah. So shortcut. So maybe after a couple of minutes, then we can pour it down.
So what's hot ATP?
Oh, actually, you guys were in radioactive area. So, so
Sorry.
don't be scared. Yeah. So we used P32.
Oh,
Radioactive P32
So
for
you
some
can
sort of
image it
activity
or
assays.
something,
Yeah. So we use that particular area for this radioactive work.
Okay.
And this is the badge.
Oh.
This is called TLD monitor badge. So this badge, and they check this badge every month, I think, to see for how much was exposure for you, like how much you have exposed to radioactive materials last 1 month or something like that. And then they change this badge every month and they give you a new badge. Yeah, they're recycled badge though, but I don't know what does they do. But yeah, this thing.
Adds up your radiation count, I guess. Right?
Radiation count or something.
Normally you want
Okay,
to sign
so-
a waiver before you put it in that working process.
Now, need to think how much materials we get. So definitely we need 25 milliliter of one small flask. We need 8. I also need this buffer into this tank. To run the gel, I also need to use the same buffer into our tank. So there are two types of buffer you can use for agarose gel electrophoresis. One is TAE, trees acetate EDTA. We are using trees borate EDTA. You can use any one of those. Some lab in few lab you will see that they use TAE, trees acetate EDTA. In our case we have trees borate EDTA, but doesn't matter. Your DNA will run fine. This is 5 times trees borate EDTA here. And
So how high do you fill it up to? Just like.
so I'm gonna dilute this stock solution 10 times here.
Okay.
How can I dilute? Any idea? I like to make it 1 liter.
100 milliliters?
Yeah. So what I'll do, I'll just take 100 ml of concentrated one. Actually, I'm doing shortcut. I should use the measuring cylinder. And this is lazy. Okay. Then I top it up to 1 liter. Is it clear to you guys what I'm doing? So I took 100 ml. I'm gonna add 900 ml water. And this is yeah, it's distilled water.
Distilled.
Yeah, milky water actually. Yeah, nice water. Not tap water.
Yeah.
Yeah, nice water.
Of course.
For our buffer, solutions, media, everything, we usually use milky water. We don't use, actually, no, we don't use any tap water. now we have our 1 liter 0.5 times. And here I add TB just to flood it, because we can adjust the level of TBE later on once we put our tray in here. We will just put our tray into this tank, and then we have to make sure that it's flooded. I'll just leave it here. If we go deeper, we'll just add later. It's no longer hot.
So should it just be room temperature? Is that, yeah?
No, not room temperature actually. It's what temperature I should say. As long as you can touch it.
Okay.
Hold it. Yeah. So, no, you cannot leave it up to room temperature. Then it will start solidifying.
Oh, right. Yeah.
Yeah, you know, it's agar and they will solidify soon. Just pour it.
Okay. Cool.
Yeah. I need to add ethidium bromide, which is here. It's the most dangerous stuff. You can use 5 microliter to 15 microliter of EDTA stock solution we have. It doesn't matter. I'm taking around 10 microliter of EDTA, and this is what I do here. You guys can have a look. So I'm gonna add EDTA. Not EDTA. Oh, what am I saying? It's ethidium bromide. Yeah. So, and then mix it.
So that's for the large one, but if we use a smaller one, do we use less?
For smaller one, we use around 80 ml of buffer,
Okay.
and you can add a little bit less ethidium bromide. Even if you use up to 10 microliter, that's fine.
Okay.
And make sure the bubbles.
Sorry, how much
Ethidium bromide I have used. This still I use 10 microliter of ethidium bromide.
If you're ever unsure about something, you can always Google and all that stuff. Solution to all of life's problems. Keep going.
So the ethidium bromide doesn't permanently damage the DNA then? Like it allows us to see it, but we can still cut it out?
Yeah. It doesn't hamper our DNA. It just ethidium bromide will just bind to the DNA.
Yeah.
Where does it bind? The minor groove of your. There is a major groove, minor groove, rich region in your DNA. So I think the ethidium bromide usually binds to those minor grooves of your DNA, and then it helps to eliminate.
Why did you mix it while it was in the tray?
Sorry.
Why did you mix it while it was in the tray?
Why did I mix the ethidium bromide in the tray?
Yeah.
Rather than stain into ethidium bromide solution later on. Yeah. So there are 2 ways you can do it. Some people will do just make the gel and load your samples, run it. Once everything is done, then they have a dedicated tray with ethidium bromide solution. What they will do, they will just soak the gel into that ethidium bromide solution for maybe 10 to 30 minutes. After that, they will take it out and wash it. They will wash it into just maybe normal buffer or water into another tray. So you can do both. This one is quite convenient for us, so you don't need to again go for just put them into that ethidium bromide solution. And in that case, in that tray, that will be really toxic. A lot of ethidium bromide will be in that tray. We just we are trying to minimize, just to minimize the what is it, toxicity. Because as long as lithium bromide is toxic, just to minimize the use of it. So that's why we are adding into the gels here. Then for this case, we don't need to check. We don't need to restain it. Is it clear to you guys? So now we are done here. Let them settle. And once our digestion is complete, then we'll load our samples.
How long does it usually take to set?
How long it will set? It will take half an hour maybe to properly set. And what you can do, you can take one tips and just in one corner you can touch, and then you will know like whether it is set already or not. We'll see samples into the agarose gel. We need to add a loading dye. So any idea why do we need this loading dye? This colored loading dye? Just to whether it will help you to see whether you have loaded your samples or not. As long our samples now is colorless media, so the gel also kind of colorless, and also our buffer is colorless, all same. So we don't know unless we have this loading dye, then we won't be able to know whether we have successfully loaded our samples into the well or not. Okay, that's why we will use it. This is 6 times, so that means we have 50 microliter of our sample, and I like to load them, all of them. I don't like to leave anything. So how much should I use from here? So if I take 12 times 6 is 60, right? And then it will be 12 plus 50, 62. I think that's okay. So around 12-13 microliter I can take from here. Is it clear to you guys? I can take around 12 microliters or 13 microliters from here, mix with all my solutions I have, around 50 microliter. Then we are gonna divide. I have to divide at least 2 to load them into the wells. Sean, confusion?
Kind of.
So this is the loading dye.
Yeah.
And it's 6 times loading dye.
Yeah.
So I'm thinking how much should I use from here. So as long as we have 50 microliter already over there, so 6 times plus, no, is it 12 times 6, 60 or what? No, 72. Oh yeah, then I can take 12, and that's okay. So 10 is already 60. If I take 10 microliter from here, that is already 10 times 6. It's 6 times plus times 10, that means already 60. And 10 plus 50 equals 60 as well. So I should take 10 microliter of dye from here. Now is it clear?
Yeah.
Capacity.
Kind of.
Oh yeah, it varies. It varies that it will vary, like it will depend on the thickness of your gel. I think we can load around 25 to 30 per well, but we'll see. If I see that I cannot load up to 30, then I'll load 25. Then I'll divide into 3 maybe. We have 15 wells available, so that's why I use more wells than to help. So now I just need to take 10 microliter of our dye. I have another. The small 20 P20.
We should have one over here. Yeah.
Can you give me the P20 small? Then yeah, 20. 220 microliter. This one. You guys will be dedicatedly using most of the times these brand new pipets. Sean got for you guys.
We did.
Thanks to Sean.
You're welcome.
So,
We have some old ones. We actually have 2 sets, so we have a crappy one as well, down in the 3rd drawer down. But yes.
Do you have enough money for Gilson, sir?
What?
Do you have enough money for the Gilson?
The Gilson.
Those are expensive.
Oh yeah. Well, this is like the Gilson ripoff.
Oh.
Yeah,
I'll show you
that's
guys
good.
this pipette. there is a lock unlock position. So first I set 10 microliter, 10 microliter, and then what I can do, I can just, now it's in unlock position. I can, unlock position means you can change. So when it is already 10, then you can lock it, then it will not change. Now you cannot do adjust. So I'll take 10 microliter of that.
How much are these utilities?
They're about $100 each. Yeah.
The real one's like $300.
Okay. We got them on sale as well. Like,
Good.
yeah.
Okay, I'd like to say one more thing here. Usually, as long they say that it is already 6 times, but I don't believe them most of the times, for sure. What I usually do, I add even more to make my sample more concentrated. That will help the sample to go down to the bottom of the well. Otherwise, they will float. You know what I mean? So that's why I forgot to mention. This guy. Basically, I'll use 50. 5 more. Just to make our samples a little bit heavy. You know, that will help it to just go down to the bottom of the well. Otherwise, there is a chance of floating. Yeah, so maybe 5 more. So I need one volunteer. Can you, anyone, spin this for me? Just give it a pulse. You can do that. Yeah. So just go over there and just give it a pulse, just to mix them together. And in the meantime, I'll just set the gel. Here, our gel is ready. Now we need to carefully take out the top like this. Yep.
Good. Sorry.
Also need to use this. And this is it. Yep. So I think our buffer level is also good. It's already, the gel is already floating. We don't need to add more buffer. Sean, I think you have the molecular weight later in your box. I'm not sure how much they, usually they will tell you how much you should load to get your bands, and also to know the concentration, how which band corresponds to what concentration. Around 6 to 7 microliter will ask you to load. In this case, I'll maybe out of 10 microliter, a little bit more, to ensure that I'll at least I'll see my molecular weight in the gel. See? So the very first lane I'm gonna add molecular weight ladder. So are you guys familiar with loading gels, maybe DNA protein? You already know, like, so this is how we do it. For me, first I like to make sure I'm just within the well, so then slowly press all the way down and then take it up. So look at my thumbs, it's still down. Don't leave your thumbs inside the wells, then you will just everything will just float up. So you take your solutions, you press all the way down and leave your thumbs like that. Don't leave it outside. Make sure you take everything outside, then you can leave your thumb. Is it clear? Yeah, then you will not then your loading should be fine. Okay. I don't use this one. Can anyone just write the sequence for me? So the very first lane was molecular weight ladder. 30 microliter. Then I load this one first. Make one. Then there is a gap. Then I load PMK Mag 1. Just 30 microliter. Got these two next to each other.
So how much are you putting in?
30 microliter.
Okay.
Yeah. So first molecular weight, there is a gap, and followed by two consecutive wells are PMK Mag 1.
So it's 30 microliters.
Kind of, yeah. Actually not 30, it's 31 microliter each. Okay. So this one molecular weight, followed by this one. And then the next one. Next one is PMKRGT. There is another gap. And then I load PMKRGT.
Do you normally do 2 lanes for each one or just one?
No, this time as long I like to load everything I have, that's why I'm separating them into two wells, and I cannot load everything into one well.
Okay.
They will flood. You know what I mean?
That's
why I'm just separating them into 2 different wells.
Okay.
And I'll cut and purify both from both wells, from both wells. So the next one, yes, there is another gap after that. So 2 consecutive well is here, and there is a gap. Then I load PJ6P3. So 2 consecutive wells are PJ6P3, then again another gap, and then I'm gonna load PT21D. maybe I'll load another 7 and then there is another gap. The very last well, again I'm gonna load our molecular weight marker. So we have marker in both ends. Okay, let's see how it goes. Okay, so let's start it. Black to black, red to red, like this. Voltage 120. 120 is quite fast. Constant voltage 7. Yeah. So now it shows that we are running our gel at 72 voltage, constant voltage. 72 is quite okay. Should be fine. When I'm here, or you guys will be working here, make sure you have your
That's cool.
Can you guys how show them? Or maybe I'll just quickly take a picture over there. Picture?
Oh, sure, yeah. So
And
turn it on.
go and just have a look.
Oh, that's cool. Do you guys want to have a look?
Yeah, just go and
It's kind of cool to look at, I think.
we'll be able to see the DNA bands.
Yeah.
Can you see? Yeah. Over our last image.
Oh, sorry. Sorry.
So if you guys, so I'm using the white tray, and you see they show us which way it should be the tray we need to place the tray. So DIA tray and the arrow this way. So I'll just put this here.
Okay.
Push him all the way. Okay.
Do you guys want to like come around?
Just in the middle.
Yeah.
Yeah. Okay, so after that, we have to wait here until it shows us ready. So we just start with the application. So we need to wait for a while, and it will show us ready and green or blue or something.
What's it called?
The color.
What's it called?
It's cooling. Sorry.
Why does it say negative 30 degrees?
Yeah, this chamber needs to be cooled down before we start.
Still recording.
So here we can use actually both this blue cartridges too, or this green we have already inside, and green is fine for the DNA gel. What you need to make sure that it's in pro option, not light option. If light option, there is no green, cyber green or green, I cannot select. So cancel this one, select the pro option. Okay. So now if you go to the dark box settings, then I will have the option for green. I like to select this green one. It's written here, dark box settings light should be green, and the filter should be this one, 575 DF. Okay. And the iris you can select either both, like either 2.8 or 0.85. They are same. And as long this is a whole DNA gel, and it's a big gel, I like to set the tray position into 3. Then press next, then press OK.
What's the difference between different trays?
I'll show you why did I select 3.
No worries.
Yeah, that's where using and buzzing it.
Okay, then once it is ready, then we have to focus. Press the focusing. Yeah, now it's out of focus. We need to minimize the brightness. Okay, this one looks good. So this tray means, oh, it's focusing now. Let's still use. So I use the tray position 3. Now I can see the whole gel. If tray position is 2, then it is here. Then we cannot see the whole gel. We will see only this portion of the gel. You know what I mean? If 1, then it will be even more close to the camera. So we will see really small focus area. Sean,
Okay, yeah, makes sense.
3? Yeah. So this one you can adjust. Now it's getting fuzzy. I think it's quite focused now. And my manual. Second. Just give it 1 second. It's manual standard. Let's see how it goes. We also need to know what's the DNA size was, the letter size. So we used Oxygen 1 kb DNA marker. DNA markers. Which one is the oxygen?
Maybe just the first one?
Is this the oxygen? Fisher Biotech?
I think so. I think, yeah.
One kb letter. Where's the 1 kb letter? I think we have this one, 1 kb letter DNA marker.
I think so, yeah.
Okay, let's have a look on our gel. 1, 2, 3. But these 2 looks bright. Which these 2 I don't know. We need to check the catalog. Tool is the RGB. and this is our Meg gene, Meg 1 gene.
Yep.
So what we need to do, I need to cut this band, these two bands from here. I need to cut these two bands from here. But the only problem is I don't have enough RGB in my sample. Yeah. And another confusion I have is with not one digested our parent vector. Looks like I have two bands. So this one at the top, I guess this is just undigested portion.
Yeah.
At the very top, I think this is just undigested normal plasmid, circular plasmid, or yeah. But here at the bottom, this should be our not digested, just linear plasmid. And my confusion is whether I should purify this both two from here, or I should just cut carefully only the dark region. Do you guys get my point? To purify this cut plasmid expression vector, I mean this one was PET321D and this one was PJ6P3. I'm just wondering which one should I consider, which one should I take? Only the small fraction from here, the very end, or which one? That's my only confusion. Maybe you can run the move it a bit longer. Okay, so for RGD was around 400 and something base pair.
Yep.
You remember? So 400 something is here. So 1, 2. According to this, you see it's not good. I cannot even see the side. How come?
Zoom in.
The very and the small one 300, 500, 700, 1000, 1500, 700 is this. So 500.
So it's about right then, isn't it?
700, 300, 500, 700. 300, 500, 700, 357, and it's like close to 400 and something base pair.
Do you guys get like the whole marker and the size idea? Yeah.
Okay, I'm a bit confused, Sean. I'm wondering, should I run a little bit longer?
You need time.
I'll just save this image first.
You have to that.
You should have an IGEN folder.
I don't know if we have.
Parts to make those agarose. We need to cut the bands carefully from the agarose gel, and then we put that band into a small microfiche tube. Then we add this buffer in it. Then we boil it 60 degrees Celsius, 60 or 70, I need to check the protocol, for around 10 to 15 minutes. Actually, it's not 10 to 15 minutes, it's just, you will see once all your gel is dissolved already. As long as you cannot see any gel left, then you can finish heating your tube. Okay, so this is the protocol we have here. So the protocol says the excise gel slice containing DNA fragment using a clean scalpel or razor blade. We have the scalpel, and then add 1:1 volume of binding buffer. So what do they mean by 1:1 volume? If our gel piece is 100 milligram, we need to wet the gel piece. We need to take the weight. And so if it is 100 milligram, then we will use 100 microliter of this binding buffer. Okay. And then incubate the gel mixture at 50 to 60 degrees for 10 minutes. We will set the heat block at 60 degrees Celsius and 10 minutes or until the gel slice is completely dissolved. So actually we have to wait until gel size is dissolved. And then you take out your solution containing your gel and DNA and put them into this column. Give it a spin, and just only your DNA will bind in this column, and everything else will just pass through the column. Okay, then you wash it. We have a wash solution here, and after then you just elute them using only water or elution buffer, twist buffer. Then the final elution step, you will have your DNA in it. That's it. This is how we get our DNA from the gel. Really straightforward, but just need to carry out, and we have to weigh, to dissolve, and those sort of things. Okay, so maybe I'll go for cut the band and go for the distribution.
Okay.
So we need 4 tubes, because 4, right? We have 4 types of
Yep.
plastic.
Yeah.
One more trick I'd like to tell you. So if our gel is too thick, and sometimes I realize that 1:1 is not good enough to even for the so what I do, I usually take a little more of this buffer just to make sure that I have enough buffer to have out the gel piece even a little bit more. Then it will help for the dissolve. During when you dissolve them, it will help if you have more buffer. If there is really less buffer, then it will take longer time. So that's just a what I usually do. Okay, so let's start again. This time we have to cut the ethidium bromide containing DNA gel, and we'll use the UV light, so we need to be a little bit careful. We have one carcinogen as well as one UV exposure, so both dangerous stuff. To level 4 tubes like this. We can take 4 or maybe 8. If it is 4, speaking 2 for each of the plasmids. So I have PMK Med 1, another one for PMK Med 1. I have PMK RGD. I'll take another one for PMK RGD. Can anyone give me red? This one's my red reds. Just over there.
No, that's the print goes.
That's one, yeah, the bottom one.
Is that? He likes to special.
What a tiny. Okay, so I also have checks 6B3. Take another one. Checks 6B3. PB21. PB21. So we need to know what's the empty tube, how much, what's the weight here. We cannot use this range. It's, we need the accurate measurement for this tube. We cannot, this one will really will not give us accurate value. So this one, switch it on. Zero, zero, zero. Okay. Now, it's 1.0356 or something. So 1.03 is already fine. Just I think they will be quite similar, all of them. Yep, 1.036 feet. So roughly I would say that this is 1.035. And then we'll take the measure again after when we have our gel selected. Okay, let's cut the gel. This one. Maybe I'll take another image for our gel before I cut it. Microliter. Okay, 30 microliter of our containing solution. So this one is okay.
Oh wow. It's hardcore, people. It's like hardcore surgery, you know?
The surgeon ever puts on
Why would we need to wear a face mask? So why do you need a full face mask?
Yeah, because
Does that protect your eyes or something?
yeah, but my hands are not protected.
Okay, right. So will I be okay if I'm like here and you?
Yes, yes.
Okay. All right.
What was our first one? What was our first one? Is it like TMK Mag 1?
First one is TMK Mag 1, yes.
Yeah. So this is what I do. Can you guys see these two small cubes? These are our insert containing MAC1 gene. Here. You see the DNA in these two cubes?
Yep.
Can you guys see? So I need to take them out. You can come
Yeah,
a
if you
bit
wanna
closer.
come
You
in.
can come and have a look.